Okay, good morning. I know you're probably going to hate me, but yesterday when I checked my mailbox, I realized that I actually will be testing the STAR test when we come back for those retesters. So we will be missing maybe 2 days whenever you come back from the Thanksgiving break, so that'll put us even more behind. So what I want to do is together we will do quiz 8 and we will turn it in today in your tray, which is the second tray in the back of the classroom where the pencil sharpener is. So this will be your actual first quiz grade for the beginning of the next 6 weeks. Alright, so let's start off, and it's just 2 problems. So let's start off with the first one. Let me zoom in so you can get a chance to copy it. Okay, you have given x squared, y squared, minus 2x equals 3 with point P at 1 square root of 5 on the curve. Find the equation of the tangent line and the normal line at point P. Alright, so I'm going to give you a couple of seconds to go ahead and just write that down. Again, this is just 2 questions. It's a very simple quiz. I figured we'd just go ahead and get this out of the way so that when we come back from the Thanksgiving break, we can go ahead and start off with the next topic, which is related rates. In related rates, you will need practice with implicit differentiation, which we would already have since we've taken care of this quiz. Alright, so let's start off with the tangent line first. I think we're all familiar with tangent line questions. So let's go ahead and insert my equation. X squared y squared minus 2x equals 3. I'm going to make this larger so that you can see it a little bit better. Alright, so usually, as I mentioned in the previous lesson, when you have something like this, that's usually a hint that you need to do implicit differentiation. Before, you were used to just me giving you the equation y equals 3x. From there, your next step would have been y prime equals 3, or you could have written it as dy dx equals 3. In this case, it's not solved for y, so what you need to do is implicit differentiation with your rules in mind, your derivative rules. If we take a look right here, those two variables are doing what to one another? They're being multiplied, so what derivative rule do we need to apply? The product rule, correct. And in this case, this one right here is the basic power rule derivative, so we can do that very, very quickly. So let's go ahead and start off. Okay, so we have the derivative of the first, which in this case would be 2x, times my second, which is going to simply be y squared, plus the first, which is x squared, times the derivative of my second. What's going to be the power rule, right? The power times my expression to the one less power, which will simply be just the power of 1, times the derivative of what's being raised to the power. So dy dx minus, and what's the derivative of 2x? 2, correct, equals, and what's the derivative of 3? 0, correct. So let me go ahead and make this smaller so it can fit into one line. Okay, from there, all I want to do is just clean it up a little bit. So if we do that, we have 2xy squared, and this can be cleaned up as 2x squared y dy dx minus 2 equals 0. Okay, the next thing we need to do is isolate the dy dx. So let's worry about this term last. Let's move everything else to the right-hand side. Now keep in mind that when we move this to the right-hand side, what happens to their signs? They change, correct. So when we move everything, we get 2x squared y dy dx equals negative 2xy squared. Put a negative plus 2, correct? Okay, now the last part that you need to do is just basically solve for dy dx. That means that you basically need to divide everything by 2x squared y, and when we do that, we get dy dx equals fraction, because we're going to get a fraction, negative 2xy squared plus 2 over 2x squared y. Alright, so we have solved for our dy dx, and this is the equation right here. Okay, next step is they actually gave us some points, so let's go ahead and say point P is at 1 comma square root of 5. Okay, so that means that we need to basically plug in these values, and that will give us dy dx. Now when we're looking for the tangent line, we know that whatever dy dx is, that is equivalent to what in relation to a line? The slope, correct. So now what I need to do is basically go ahead and substitute the values of these points. So this x now becomes 1. This y now becomes square root of 5. Plus 2, and then this x now becomes 1, and this y now becomes square root of 5. Okay, so if I continue to clean this up, which is right here, square root of 5 squared just leaves us with 5. 1 squared, I know, is simply just 1, so that one goes away too. And then if I continue to clean it up some more, I get negative 2 times 1, which is negative 2, times 5, which is negative 10, plus 2, over 2 times 1 is 2, times square root of 5 is simply 2 square roots of 5. And again, simplify some more. Negative 10 plus 2 is equal to negative 8. One more time. 2 can go into both of these. So negative 8 divided by 2 would be negative 4. And then 2 divided by 2 would be 1, so we're left with the square root of 5. So negative 4 over square roots of 5, and that's also equal to my slope. Let me go ahead and put that in parentheses so you know that it's slope. Final step is to go ahead and just write it in the form of a line. So therefore we have y minus square root of 5 equals negative 4 over square root of 5 times x minus 1. Correct? If we continue to do a little bit more simplification, basically let's just distribute this slope to everything inside the parentheses. I would get negative 4 over square root of 5x minus, oh actually it'll change into a plus 4 over square root of 5. Get rid of this negative right here. Then my last step would be to basically move this square root of 5 to the other side. When I move that square root of 5 to the other side, then it becomes a positive. So let me go ahead and make that a positive. Delete this one because I've moved it. This can be expressed as square root of 5 over 1. I can continue to combine these two right here. They have a common denominator of square root of 5. So if we continue, the only thing that will change will be this one. So this one will have square root of 5 as a denominator, and this is the way that I do it. You may not do it this way whenever it comes to finding common denominators, but either way is fine. Square root of 5 divided by 1 is simply square root of 5 times square root of 5, which is 5. So that is equivalent. Now because they have common denominators, what I can do is I can combine them. So these two will now become 4 plus 5, which is 9. Keep my denominator. And that is my tangent line equation. Y equals negative 4 over square root of 5x plus 9 over square root of 5. Let's check to see if we're right for tangent line. She got negative 4 over square root of 5 x plus 9 over square root of 5. Perfect. That's exactly what we got. Now for the normal line, remember that normal is a synonym for perpendicular. So therefore what I want you to do is to basically do the exact same thing. Let's go up to our slope. Our slope is negative 4 over square root of 5. Okay, well, if we're talking about a normal line, aka perpendicular, we know that perpendicular lines have negative reciprocals. That means we flip and change the sign. So when we flip this, my new slope will now be negative square root of 5 over 4. But then we got to take that negative reciprocal part, so that means we change the sign, and that negative will change to a positive. So my negative reciprocal of this slope is positive square root of 5 over 4. You're going to use the exact same point, so you're going to say y minus square root of 5 equals positive square root of 5 over 4 times x minus 1. Go ahead and distribute everything, combine like terms, find a common denominator, etc., and you should get the equation of a normal line. So go ahead and do that, and then I will start with number 2. I'll actually tell you what you should get, and I'll start with number 2 in the next video.